Dynamic arrays are commonly used in game engine for managing collections of game objects such as characters, enemies, items, and environment. For example, a game engine might use a dynamic array to store a list of all enemies currently active in a level. As new enemies are spawned or destroyed, the size of the array can be increased or decreased dynamically to accommodate the changing number of enemies. We use dynamic arrays in situations where size of the array is not known in advance or may change over time. Overall, dynamic arrays are useful data structure in game development because they allow for efficient and flexible management of large collections of game objects and assets. Let's implement that beast in our game engine. And let's start from a simple one, just create array and destroy it. First is define the just translate type to type pointer, then call to create preprocessor that will call create function, and we do it in this weird manner just to call create only with type as an argument. That will allocate memory for header and default number of elements. Assign all fields in the header to store array size, its capacity and stride. And return pointer to first element in the array, and we can operate on it the same way as with ordinary arrays. For this specific dynamic array implementation, I was inspired by KOHI engine, so credits go to Travis, and link to his series will be in the description. So we know how to create and destroy dynamic arrays, but it isn't much. And we need functionality for adding elements to make it truly dynamic. For adding elements, we simply copy value of the element to the array indexed by length, and then increment length by 1. So we can add elements, that's cool, but what will happen if we go beyond the capacity of the array? On the first glance, nothing bad is happen, but it depends. When we write to memory that is not acquired by our dynamic array, it overrides the memory that can be acquired by other parts of the program and can lead to undefined behavior. That's particular bug called buffer overflow. To prevent this, we should reallocate array and increase capacity every time when we pass the array boundaries. That's where resize function comes in handy. It allocates new array, twice big, copy old array to the new one and destroys it. Let's now check more complex data. We create enemy structure that will hold its name, position, health and its charges. Create dynamic array for enemies and push several enemies to it. Create additional function to log enemy stats, iterates through enemies in a for loop and call to this function. Tests are passed without crashes.